Okay, Clay. So this is, and let me get a better color because I just, you know how I am. I like bright colors. All right. So this is example 1 because you've got 2 problems to finish on your test. And I'm going to do one that's like the first one and then one that's like the second one. And so we'll just go through it. So here's the first problem. X to the 4th plus x to the 3rd plus 7x squared plus 9x minus 18. And it wants us to use the integral root theorem, which that means the factors, let's see here, my pen went away. The factors of 18 over the factors of 1. So we really only have to worry about the factors of 18. Okay, so that is, in this case, plus or minus 1, plus or minus 2. You could pause the video and try to see if you can figure it out first, then compare them with my list. Plus or minus 3, plus or minus 6, plus or minus 9, and then plus or minus 18. Okay, so then the next thing I'm going to do is, it says here sketch a graph, and I'm going to play this little video here for you because you can just sketch a graph on your test when you get it. But let's go ahead and play this video right now, and it will show you what I am actually looking for. Okay, so Clay, this is where you're going to want to pull out your graphing calculator, and this is the best way to do this at this point. I'm going to go ahead and I put the equation in after I've done part A where I've listed all the possible roots. So all the possible roots of negative 18 in this case. And that's the real roots. So what I'm going to do now is I'm going to go to second graph, which is the table. Okay, and what I'm looking for, and you'll see this right here, and I'll do some still shots of this too and circle them and explain everything, but I'm looking for the zeros. So 2 zeros that I can divide out synthetically, and then I can figure out what the imaginary roots are, because you'll have some imaginary roots on this as well. So that's kind of what I do here. Now, let's look at the graph, because you're also going to have to sketch a graph of this. You could probably, oh gosh, I haven't changed my windows. Hang on. Zoom, let me go zoom standard. Okay, 6. Let's take a look. All right, so I probably need a little bit more on the negative y. So I'm going to come down here and I'm just going to say negative 50. And then let's look at the graph, see if I've covered it. Yes. Okay, but there's still something else missing. Okay, so we have 2 zeros here, but we don't have, and I'm going to just use the trace button for now because you've already figured this out by looking at it. But one of them is negative 2. If it lets me get there, you'll see how it's close. And then the other one, oops, go the other way, is 1. Okay, and it's kind of close. Yeah, you see that. So anyway, those are the things you're going to divide out synthetically. But this one will have 2 imaginary roots once you get done with it. So that is the video for this problem. And then I will have another one and another problem because I want to give you 2 examples. So here we go. Okay, so now the next step after that is to come back here and synthetically divide out the zeros we found. If you noticed, I was circling things during that video to show you. So I'm going to start by dividing out negative 2. So I put, you know how I like to use the bird cage, and put negative 2 up top, and then my coefficients, which are 1, 1, 7, 9, and negative 18. Okay, so I'm going to come down here. I'm going to put my little arrow, drop it down. That's 1. 1 times negative 2 is negative 2. I add those together, that's negative 1. Then I do negative 2 times negative 1, and I get 2, and I put that under the 7. I add those together, that is 9. Then negative 2 times 9 is negative 18. And so when I add negative 18 to 9, I get negative 9. And then when I do negative 2 times negative 9, it gives me a positive 18, which means I have no remainder. And so that is how we divide that one out. Now, let me make that a little smaller for just a second. Okay, I needed to make that a little smaller so I could fit the other synthetic division in. Okay, so let's put our next one, which was negative 1, or just positive 1. So now we're going to take these same numbers right here, and those will be the new things that we divide of. So I'm going to put 1 in the bird cage. Then I'm going to put 1, negative 1, 9, and negative 9. Okay, and we're going to do the same thing. I'm going to drop down my 1. 1 times 1 is 1. Put that up there. That equals 0 when you add them. 1 times 0 is 0. 9 plus 0 is 9. And then 9 times 1 is 9. And so we have no remainder again. So this one would have been x to the third minus x squared plus 9x minus 9. But then we divided out another 0 right here. So now it is x squared plus 9. So we know that 2 of our zeros are negative 2. And I don't know if she wants them in coordinate form, so I'm going to put them in coordinate form for right now. Negative 2, 0. And then also 1, 0. And then we have to figure out, well, with x squared plus 9, let's just set it equal to 0. Okay, so I'm going to go and I'm going to subtract 9. So x squared now equals a negative 9. Now, I'm going to give you a second and think about that. I have to take the square root. So x is going to equal plus or minus the square root of a negative 9. And you need to take a second and figure out what that is. All right, take a second. You can pause the video, whatever. I'm going to go ahead and just say it right now. So it's x equals plus or minus 3i. Okay, so you will have a plus or minus 3i as your other roots. Okay, so those don't intersect the x-axis, so we're not going to create them as a coordinate. Let me go ahead and erase this so this doesn't confuse things. So negative 2 and 1 and plus or minus 3i are your 4 roots for this particular problem. Hopefully that helps. And we're going to go do one more example. Okay, Clay, so here's the second example, which is similar to what you're going to be doing on the next, on the rest of the test. You only have 2 problems. By the way, you did really great on the rest of the test, so you only have to do 2 of these problems. So I'm going to go ahead and, let's see here. This is similar to the other one that we just did. So I'm going to list all the possible roots. So it's all the factors, let me get this written right, factors of 12 over the factors of 1. So again, you only have to worry about the factors of 12. So those are plus or minus 1, plus or minus 2, plus or minus 3. And you're going to have to list all these on the test. Plus or minus 4, plus or minus 6, and plus or minus 12. Okay? Those are all the ones you're going to be looking at to find the 2 real zeros, or I should say the 2 rational zeros in this one. Because in this one, you're not going to have imaginary numbers, but you're going to have irrational roots. So we'll talk about that more as we go. So let me go ahead and play this video again, like I did the last time, talking about this particular problem. Here you go. This is an example number 2, and this is after you've done the part A of the questions where it says list all possible roots of the integral root theorem. So in this case, the possible roots of 12, because there's no coefficient on x to the 4th. So what I'm going to do is I'm going to do what I did before in the other video. I'm going to just go to second table, and we're going to look for the zeros that we know. Oh, look at that, right there on the same page. So negative 2 and 0 and 2 and 0, okay? So what I'm going to do then is I'm going to use those to divide those out synthetically. And again, I'll have some still shots in there. But let's look at the graph so you can see it. Interesting. So this one's got 4 roots, and it looks to me like, well, let's see if I can zoom in a little bit, because that's kind of what I want to do here. Let's see here. Let's make our y minimum less so you can see more. Window. Let's just make it -2. Okay, and let's see what it does. Okay, so you can see it comes down a little bit below the x. So you're going to have 2 of the real ones that we found. Well, they're all going to be real in this case, just to say ahead of time. But 2 of them will be irrational. In this case, you're going to have a 2 and a -2, which we've already seen. But then you're going to see what's left when we solve it on Explain Everything. So that's what you've got here. Let's move on, and I'll have this in Explain Everything as well as the problems. And sorry if I sound really loopy today, but I'm kind of not feeling very good. So here we go. Okay, so let's just continue this on. So we know here, because I circled these as well, and you saw them on the table when the video was playing, we need to synthetically divide out our -2 and our 2. So I'm going to start with -2, and I'm going to write a little smaller this time so I can get it done. Now, this one's a little different because you don't have an x to the third. So you have to put a 0x to the third and a 0x when you divide synthetically. So we're going to have 1, and since we have nothing cubed, we have to put a 0. Then we're going to put a -7. And again, since we have nothing times x, we have to put a 0. And then 12. These are kind of like, I always call them like placeholders. Let's see here, placeholders. Because you can't synthetically divide unless you have something in those places. So I'm going to do this really quick because you know how to do it. So 1 times -2 is -2. We add that, we get -2. -2 times -2 is 4. We add those together, that's -3. -2 times -3 is 6. Add that together, we get 6. 6 times -2 is -12, and so we have no remainder. Again, I take these 3, which if I was done, this would be x to the third minus 2x minus 3x plus 6. But we're not done because we need to divide 2 out. So I'm going to take these coefficients, which are right here, and divide out negative or positive 2. So we have a positive 2, and we're going to put a 1, a -2. Sorry for the dinging. I have messages coming in. A -3 and a 6. Okay. So I'm going to go like this, and I'm going to go quick again. 1 times 2 is 2. -2 plus 2 is 0. Then 2 times 0 is 0. Then we have -3. 2 times -3 is -6. So that leaves us no remainder. So that means our final equation or our final statement or expression is x squared minus 3. Now, if it's x squared minus 4, you know you have x plus 2 and x minus 2 because they're the difference of perfect squares. But when it comes to x squared minus 3, you can again just set it equal to 0 if you want, or you can factor it, but it's just add 3, and then you get x squared equals 3, but then x is plus or minus the square root of 3. Okay, we can put all of these into coordinate form. Again, I don't know how Mrs. Kilner wants it listed, but our first one is -2, so we'll say -2, 0. Our second one was 2, so it's 2, 0. But then we have these two, so root 3, 0, and -√3, 0. And those are listing all the exponents or x-intercepts, real and imaginary. And in this case, irrational. So hopefully that helps. Okay. All right. So I'm going to also send the test to your mom, and she's going to print it out so you can finish it. And then once you're done with it, please have your mom email it back to me so I can send it to Mrs. Kilner and let me know how you did. I'm really proud of you, Clay. You've had a great year and you've done a lot of hard work. And if you need to, keep watch this video a couple times before you do the test. And I wish you the very, very best. And we'll talk to you soon. Take care. Bye.